Hi everyone! So let's get started. Trigonometry is derived from the Greek words trigonon meaning triangle and metron meaning measure. It's important to note that trigonometry almost exclusively deals with right-angled triangles. So a right-angled triangle looks something like this, where one of its angles measures 90 degrees. Trigonometry itself studies the ratio between the measures of the angles in the triangle and their sides. So for instance, if I had this triangle and I had my sides to be 3 and 4, well, using our previous knowledge of the Pythagorean theorem, I should be able to find this side, which is known as my hypotenuse. So this is my hypotenuse. And we know that my hypotenuse squared equals the side squares summed up. So 3 squared plus 4 squared. So my hypotenuse squared equals 9 plus 16. My hypotenuse squared equals 25. So my hypotenuse is the square root of 25, which equals 5. So I know that this side equals 5. So now I have a triangle with 3 side measures. So what if I wanted to find the angle measure, this angle measure relative to the sides? So let's call this angle theta. And theta is a relatively common Greek symbol which we use to represent missing angles, which we want to find. So the basis of trigonometry lies in what we call SOHCAHTOA. S here stands for sine, C for cosine, and T for tangent. Now all the O's you see here stand for the opposite side, and my H is my hypotenuse, A is the adjacent side. Firstly, it's important to note that the hypotenuse is always the longest side of the triangle, and it's always opposite the largest angle. So here we know that the interior sum of a triangle is 180 degrees. If this angle is 90 degrees, then no other angle can be bigger than it, so this is the largest angle in a right angle triangle, so the hypotenuse is always opposite it. Okay, so if I wanted to find the measure of this angle, well, using this formula, I can say my sine of this angle, S sine of angle theta. Now, sine is actually the short form for sine. Somewhere along the way, someone got lazy and decided to drop the E, yeah? So sine of theta would be, well, opposite over hypotenuse. So the side opposite to theta is 4, and my hypotenuse is 5. So the sine of that angle theta would be 4 over 5. What if I wanted to find the cosine of that angle? Well, cosine, or short cos of theta, would be, well, we have adjacent over hypotenuse. So my adjacent side to this angle theta is this side 3. So cosine of theta equals 3 over the hypotenuse, which is 5. So my cosine of that would be, cosine of this value theta would be 3 over 5. Finally, if I were to do tangent of theta, well, tangent of theta is opposite over adjacent. The opposite side is 4, and my adjacent side is 3. So the tangent would be 4 over 3. Let's do another problem. If I had a right triangle, and I had my sides to be 5 and 4, and this would be my 90 degrees. Well, firstly, before we start off, we need to know the measure of the hypotenuse. So let me just call that x for now. So x squared would be equal to 5 squared plus 4 squared. X squared equals 5 squared is 25. And 4 squared is 16. X squared is 41. X would be the square root of 41, so x, since it's not a perfect square, we just leave it like that. Now, if we were to find the sine of this angle theta, let me just rewrite the formulas from before. We have sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And tangent equals opposite over adjacent. Okay, so this is just a catchy, let's say, phrase to remember the formulas. And as you go along, this is going to become increasingly familiar. So firstly, if I was to start with this angle theta and to find the sine. Sine theta is opposite over hypotenuse. My opposite is 4. So the opposite side to the theta is 4. And the hypotenuse is square root of 41. So that would be the sine of theta. The cosine of theta, so the cosine is adjacent over hypotenuse. The adjacent side to this angle is 5. So we have 5 over the hypotenuse, which is square root of 41. And finally, the tangent of theta is opposite over adjacent. So my opposite side is 4 over adjacent side, which is 5. So 4 over 5. Okay, so now let's try to find the measures of this angle. So let me call this angle phi. Okay, that's another Greek symbol. So the sine of phi would be sine again, opposite over hypotenuse. The opposite side to this angle is 5. So we have 5 over square root of 41. Now my cosine of that angle phi is adjacent over hypotenuse. So the adjacent side to this angle is right here. It's 4. So 4 over my hypotenuse, which is square root of 41. Finally, we have the tangent. Tangent of phi equals opposite over adjacent, and my opposite is 5 over 4. 5 over 4. Okay, so if you look at these two values, you might notice something common. Well, the sine of my angle theta, sine of theta, it equals my cosine of this angle phi. So these two are the same, and these two are the same. And this is no coincidence, okay? This always happens. So the sine of an angle, theta, let's say, is equal to the cosine of the complementary angle. So complementary angles add up to 90. So sine of theta would equal the cosine of 90 minus theta. Okay, so what I mean by this is, let's go back to the triangle here. We know that the sum of the interior angles is 180, right? So this angle by itself is 90. So the measures I'm left with is 90 for these two sides added up together. So my total should be 180, and 90 is this angle. So I'm left with 90 degrees split between these two angles. So if this angle was 40 degrees, this angle would be 90 minus 40 degrees. Similarly, if this angle is theta, this angle is 90 minus theta. Okay, so just like how the sine of this theta equals the cosine of the complementary angle, we say that the sine of theta equals the cosine of 90 minus theta. And this is also true for cosine. So the cosine of theta equals sine of 90 minus theta, right? The cosine of this theta, 5 over root 41, equals the sine of the complementary angle, which is the sine of phi and here that they are the same. Okay, so this is an important concept that we can grab from this. See you in the next video.